Hi, my name is Reyes. I'm a computer science major at Loyola University Chicago. This is a project I worked on along with my mentor, Dr. Eric Chantin, and this project, Traffic Analysis for Website Prediction, concerns the issue of website fingerprinting, what it is, how it works, and what significance it may have in today's world of computing and networking. So to start, the internet, as we all know, is a constant exchange of information, made possible by numerous routers used by many different companies, individual users all around the world, and ultimately what is happening is between different computers, different servers, we're sending information to one another. And the goal is just for info to be transmitted from its sender to its destination. However, that comes with the issue of privacy, as it's easy to intercept the data being transmitted throughout the internet. Oftentimes, we are utilizing services such as ISPs. We're able to see all the websites that you visit, everything you download, because you're able to see the IPs that you're contacting through the internet. And oftentimes, because these are commercial companies, we don't know what they are doing with the data that they're accumulating from its users. They're able to see, as I mentioned before, the requests that you make to servers, and they're able to see what servers send back to you. And because of many different issues, a lot of issues that have come up in recent news, common issues including government surveillance, big data in general. If we are sending a lot of sensitive information, or perhaps we just don't want to be profiled by many different commercial companies, this can pose a problem. And as such, we might turn to alternatives or methods to help hide our data, such as encryption, VPNs, or a browser such as Tor to help us hide our browsing activity. Oftentimes, when we use encryption, they confuse whoever may be watching by connecting to multiple different computers, and so they're not able to see where the final destination for your info is going. A lot of times, this comes with the consequence of upload or load times. However, for many users, this is often a worthy trade-off. So then the question becomes, would it be possible to counteract these methods anyway? And a possible answer might be website fingerprinting. Even though a user has an anonymized encrypted connection, they still leak packet data when they browse the internet. And if an attacker were to collect these data, they may be still able to try and guess what websites the user is visiting. And here's how that would work. Suppose the red squares are outgoing data, and the green squares indicate incoming data. And then with time, suppose the attacker collects all this data. And then in this scenario, this scenario demonstrates what 3 different websites would look like and how their packet data might differ. And the packet data would differ because different websites require different resources. They have different data, different sizes, and of course, it would look different when a user tries to download and send info to these websites. So in theory, if an attacker were to collect your packet data and they already had a preset of what different websites looked like, they'd be able to determine what website a user is visiting. And on this slide, we would suppose that this website belongs to luc.edu. All they would need to know is the number of packets that you're sending, the size of the packets, and the direction that they're going in order to make this prediction. We would call this bundle of data a network trace, and that would be how you would conduct, in theory, a website fingerprinting attack. With that, it becomes very important to evaluate the effectiveness of a website fingerprinting attack, especially since it has potential to be used against many different users. With that, so many studies have been conducted in order to evaluate its potential, and many of these studies have come up with their own algorithms and methods, and we've seen over 90% accuracy in identifying websites just from packet data. A lot of these studies use different algorithms in order to test and train our data, such as KNN, which is what we actually used in our own study, SVNM, deep learning, and a lot more, and they all often have different features such as total incoming or outgoing packet size, number of incoming, outgoing packets, timing, binning, and more. Our study had 104 features in it, so we had a lot of variety of data that we were collecting on it. There are two types of studies that you can also do on data. Either you can try and identify packets based on a closed world simulation. This is where you try to identify websites individually, and you would create a sample website such as 1,000 possible websites. So essentially you would be trying to identify a website each network trace belongs to. Whereas open world, you'd be looking to identify websites from a small pool of desired websites rather than trying to identify all of them individually. So it's more of a either it belongs to this category or it belongs to the other one. And this could be applied to government surveillance, as perhaps a government that blocks websites that they don't want their citizens to see. They would be looking for websites that belong to the small set versus the large set that we would say is unimportant. As studies try and evaluate the effectiveness of website fingerprinting, there's also important to evaluate how exactly we will treat each network trace. The way we browse the internet is not exactly so linear. Either we can try and treat the packet data as just one web page, or we can see that a user visits multiple web pages, or sometimes a user will visit multiple web pages at the same time. And if you're trying to identify what web page a user is visiting, this can pose a problem, as if you try and go back to the squares from before, if you have packet data that's being mixed up in each other, and then you try to identify which website comes from based on that, then you're not going to be able to get such an accurate prediction. So it becomes really important to consider these overlaps in packet data. Sometimes packet data can also be partial. Perhaps the user lost connection or other reasons where the packet data did not end up becoming complete. For our research, we collected our own data set based on Alexa top 200 most visited websites. However, after excluding duplicates, we actually only ended up with 118 websites. How this data was collected was, we visited each website about 1,000 times, and to generate the overlapping data set, we randomly visit one website, then either after 10 or 20 seconds, we then visit a second website. And this process repeated about 17,700 times. This data we collected in the Tor browser, and we processed the raw data using a QML algorithm. Our research in particular really focused on evaluating the effectiveness of the sectioning algorithm. Many different algorithms have been used to identify packet data, and we found that the sectioning algorithm overall has worked best, especially when used in simulation data. Therefore, this research is to evaluate its effectiveness on real-world data rather than just simulation data. And the point of the sectioning algorithm is to try and to eliminate the impact of overlapping websites. And the problem with overlapping packet data is that because the data gets mixed into each other, as I mentioned before, it affects the rest of the prediction. Therefore, it's really important to try and minimize their impact. And in theory, if you section lots of data many times, eventually you may end up with enough sections that the overlapping data no longer is as significant, rather than if you treated it as a whole piece by itself. This graph demonstrates the impact of overlap when it's at the head part of the data versus at the tail part. We see that there's better accuracy when the overlap is at the tail part of the section rather than at the head part. This graphic demonstrates how training and testing works. First, as you can see, we have many different sections. Depending on how many sections we choose to split our data into, we will have different websites, and we will rank which website is most likely for that section, which leads to our prediction set. Then we will, since this graphic is about 5 different sections, we would have 5 different prediction sets. And then we perform majority vote on all those predictions in order to obtain a final prediction set. This means that this is our final prediction for what website this packet data most likely belongs to. So this is our process in how we would get a prediction from our packet data. So we would add our packets, we would partition the packets or section them, we would train and test our packets, and then reach a majority vote. We also use the KNN algorithm in order to train or test our data. This graph demonstrates the effectiveness of sectioning, and we see that after sectioning the data many times, we reach about a 70% accuracy versus when using only about 2 or 4 sections. So there's a trend for this website where it will eventually reach about 70% accuracy no matter how many sections you use. However, when you use less sections, the percent overlap starts to matter more and how accurate you'll be able to identify the website. And as expected, you would see that the less overlap, the more accurate you will be able to identify the website. However, if there's not that many overlaps to start with, then sectioning it way too many times will end up affecting your accuracy. This is also true for this website as well, although this website fared much differently than the other one, and actually all percentages overlap increased in accuracy after using more sections. There seems to be a leveling of accuracy that you seem to attain after sectioning so many times. With that, it's important to evaluate countermeasures against website fingerprinting, as there is considerable accuracy when used against leaked packet data. And some of the methods you could use are padding, noise, and delay. And here's how that would look like. So again, we have our squares. And so if we were to pad our data, we would make the data sizes more larger than they actually are. However, the downside of that would be there would be more data for the user to download. However, that also means that it changes the network trace from what is expected. So it's harder to identify what the trace actually belongs to. We also can add noise, which means we would insert gibberish into the trace in order to make it more difficult for an adversary to identify. And we also can add delay, where the sequence of packet data come later than they're expected to. However, with that, as I mentioned before, it would make it take longer for a user to download data. This demonstrates different encryption protocols one can use in order to help hide their leaked packet data. As you can see, these come with costs and benefits. Here's accuracy, latency overhead, and bandwidth overhead. As you can see, using no defense at all, the accuracy for being able to predict your packet data is 91%, although you do get a perfect rate of 0% for both latency and bandwidth overhead. The best protocol you can use, Tamara, promotes a 10% accuracy rate. However, the latency overhead is a huge drawback of this protocol. So a lot of times it is mostly a cost and benefit sort of situation, as perhaps if you had a desktop with a really good connection, the latency would not be so bad of a drawback. But if you were on a smartphone and you didn't have such good hardware and you needed all the bandwidth and speed you can get, then it would not be such a good option after all. But other options do promote, although they still do have some bandwidth overhead or latency overhead, they do also promote a similarly low accuracy rate. That makes them somewhat viable as an option. So in summary, website fingerprinting attacks are a type of attack where an adversary is able to predict the activity of a user, what websites they're visiting, based on packet data that they send out. And the adversary in this case would be state-level agencies, think like government organizations, ISPs, or Tor entry relays. And the question becomes, is this a realistic attack? Most likely because it is very accurate. It does work in theory. Is it practical? Perhaps maybe, because me doing the work personally, it's a lot of data to parse through, it's a lot of knowing what to look for, and I imagine doing this on a very large scale that it would take up lots of storage and a lot of computing power. However, if you do have the resources, I imagine this will not be a problem at all. And preventable, using protocols, yes, but then there's also some overhead that you have to consider as well. Here are the references to which we credit our work towards. And thanks so much for listening. If you have any questions, feel free to email both of us from the emails below. I really appreciate you listening, and I hope you have a good one.
And now I'd like to welcome in Daisy Reyes. Daisy, welcome. Thank you for your terrific talk. How are you today?
I'm good. How about you?
Well, thank you very much. We've got some questions coming in via Discord and some other channels, so we can dive right into them. First one for you, Daisy, asking, do you collect metrics on effectiveness degradation based on the number of concurrent sites visited overlapping?
We did. We have multiple graphs that demonstrate that the more overlaps or sectioning that we use in our analysis, the more that they tend to kind of lean towards the same effectiveness with number of sections, and they tend to start to go towards the same number of accuracy. That's all I can kind of say on that topic.
And this may be a related question, so I'm going to work in here now, Daisy, just in case, or if it's something different, feel free to clarify for me. But a question from Jim came in on Zoom asking, did you look at overlap of more than 2 websites?
My work data specifically is more just on 2 websites only.
Okay, let's move on to the next one. We got, okay, how does the within site variation compare to the between sites variation?
That's a question my mentor could answer very well.
Right, and so maybe we can talk about, I know, Eric, you said Dr. Tan Chin, I think, is he going to join on Discord as well? Will he be available for some questions afterwards as well?
I thought he'd be able to.
Yeah, I think we heard on some of the back channel that he may be available. So that's a question that was on Zoom that we may be able to get posted to Discord and post to him as well. Let's see what else we got coming on.
For question 2, we did not measure that.
Okay. Thank you for that. Okay, now we got one from Edward on Discord as well. Do you mind clarifying what does website and web pages mean? For example, a single user visiting Facebook.com would trigger multiple concurrent requests, a variety of web resources.
So it would just be every individual website loaded by the user.
Okay, and then a follow on to that one. At the same time, a user could be visiting 10 different distinct websites simultaneously via Tor or VPN.
Right, so a user can open multiple tabs at the same time. So that's why we're measuring for overlaps here, is to make sure that we account for that, because not all of us browse the internet just by opening one website, another website, in sequential order. A lot of us are going to open multiple tabs and be browsing multiple sites at the same time.
Thank you for that. Now, being a student, I'm just interested, your FlowCon experience, how you heard of FlowCon, how you became involved, so maybe you can share some of that experience, and maybe as a follow-up to that, what are some of your plans once you finish your undergrad?
Well, it was suggested to me by my mentor, and it just seemed like a good idea to present our work here. And as for my future plans, I'd like to work in something technical with environmental science, or perhaps there's a lot in the air for me right now, personally, since I'm still midway through college. But that's one thing I like to do, is work with primarily the data science, and with an environmental science field, there's a lot of that. Or if not, I'm also interested in other kinds of data science sort of work.
Terrific. You are picking great fields, no doubt about that. Another question came in. Did you get any insight into identifying sites that users browse with similar behavior, but are different sites? Like classifying sites based on the ways users interact with them. And if you need anything repeated, feel free I can repeat any questions.
So we did not collect real user data. So okay. That's something I'm not going to be able to answer.
Sure. How about another question? Did the traffic collection for this research occur near the client endpoint or upstream, near the web servers? Or is this not relevant to the analysis?
I don't believe this is relevant to analysis.
And let's get to question number 8. How about some of the list of the features that you used?
Question 7.
Yeah.
It's near the client endpoint.
Near the client endpoint for number 7. Okay. How about question 8 here? What are some of the list of some of the features that you used?
So the features that we did were number of outgoing and incoming packets. Other features we did were the size of the packets, and then the samples of packet sizes.
Terrific. We're going to get one more question in here, Daisy. Last one for you. Have website fingerprinting attacks been used in the wild?
As far as I know, I don't believe so. But there's a lot of research being done on website fingerprinting. Well, there's no way we would know right now. Perhaps they've been attempted before, but it's really important to see how effective they can be if they're used by an actual adversary. But as for right now, they could have been attempted before. We don't know for sure, but as far as we know, no.
Daisy, thank you very much for being a part of FlowCon and getting to help make the conference better. We appreciate your time and efforts and sharing your work.
Thanks so much. Thanks for having me.
Our pleasure.